Good morning, everyone. Let us start. Today we shall.
Morning, sir.
Good morning. Today we shall compare the Himalayan rivers with the Peninsular rivers. Now I shall present my screen. So this is the table number 3.1, comparison between the Himalayan and Peninsular rivers. And here in this column, okay, the aspects for comparison or the bases for comparison are given here, and here in the next two columns you will find the characteristics for comparison. Okay, so on the basis of place of origin here, on the basis of place of origin, so let us compare the Himalayan rivers with the Peninsular river. So on the basis of place of origin, Himalayan mountain covered with glaciers. That means Himalayan rivers are originated from the Himalayan mountains covered with glaciers. And for the Peninsular rivers, these rivers are originated from the Peninsular Plateau and the Central Highland. And next we have this natural flow. Okay, so on this basis, Himalayan rivers are perennial. That means the river contains water throughout the year, because these rivers receive water from glacier and from rainfall, and hence perennial. Whereas Peninsular rivers are seasonal. That means the river flows only during the rainy season. This is because the Peninsular rivers are dependent on the monsoon rainfall. Okay, so when the monsoon rainfall starts, then the river starts flowing. Then types of drainage. Okay, so Himalayan rivers are these antecedent and the consequent rivers. Okay, are antecedent and consequent, leading to dendritic pattern in plains. So about the meaning of antecedent, I have explained you earlier. Okay, antecedent means the river being older than the landform it cuts through. Okay, so that the river erosion kept pace with the uplift of the landform. Here I will show you the diagram again. See here. See, this is the beginning of the landform. It was a plain area, and a river is developing here. Okay, a river starts cutting here, and in due course of time, this a mountain range. Okay, a mountain range is uplifted here. But due to the downward cutting of the river, okay, this mountain is able to cut through, because the river erosion kept pace with the uplift of the landform, and hence this river is older than this mountain range, and hence this river is known as antecedent river or antecedent stream. Okay, the river being older than the landform is known as antecedent. Remember, here in this case, the river is older than this mountain range, because the river was developed before the upliftment of this mountain. Okay, and next we have this consequent. Okay, consequent rivers means a river that develops on a newly formed surface, such as a recently uplifted coastal plain or the limb of a newly formed anticline and follows in this slough. That means consequent stream means a river which follows the slough. Okay, for example, this is a slough and a river is developing here, and such type of river is known as a consequent. Okay, so let us assume this is a newly developed landform and a river is start cutting here following the slope of the lane, and this is known as consequent stream or consequent river. And most of the Himalayan rivers form dendritic pattern, that is a tree-like pattern. Okay, here we have this, so this is what we call dendritic pattern. A river together with the streams tributaries look like a tree. Okay, branches of a tree, and this is known as dendritic. And most of the Himalayan rivers form dendritic pattern, and whereas for the peninsular rivers, okay, these rivers are superimposed, rejuvenated, resulting in trellis, radial and rectangular pattern. Okay, so what do you mean by superimpose a river? So for this I will show you this diagram here. Okay, actually see here in this case, in the first case, the underlying rock structure, okay, is totally different from the overlying one. See here the overlying structure, okay, has a horizontal bedding planes, and whereas the underlying structure has a folded one. Okay, the underlying has a folded structure, whereas the overlying one, the surface is covered with these horizontal beds. Okay, that means the underlying structure is totally different from the overlying structure, and a river start developing, okay, here on the horizontal bed. A river is start flowing here on these horizontal bedding beds. Okay, and as the time passes, the river starts downward cutting, and the whole these horizontal beds, okay, have been removed due to erosion process here, and the underlying this rock structure, that is this folded structure, okay, is exposed, and the river start cutting. As you see here, the river start cutting on the newly this folded structure, and such type of river is known as the superimposed. Okay, remember, superimposed stream is a pattern of rivers, okay, which have been let down onto a very different underlying structure from the one on which they were formed. So here in this case, this river was start forming, okay, on the horizontal beds, and just below the horizontal beds we have these folded beds. Okay, and in due course of time, the horizontal beds have been removed by the erosion process, and the river starts cutting, okay, the folded structure. The river starts cutting on the underlying structure, and such type of stream is known as the superimposed stream. Okay, and rejuvenated. Okay, what do you mean by this rejuvenation? Rejuvenation means resurrection. Okay, resurrection, the renewed vigor of a once active process. Okay, actually here rejuvenated streams and rivers are the rivers which regain energy due to the uplift of the land through isostasis or by a fall in the base level, that is fall in the sea level. And here I will show you, okay, a diagram here. See, you must know that the base level of erosion of every stream is the sea level. Let us say a river is flowing here. Okay, this is the cross-sectional river, and here let us say this is the this side we have the sea. Okay, let us say this is the sea level, and remember, you must know that sea level is the ultimate base level of erosion. That means if the bed of the level, okay, if the level of the river bed is equal with the level of the sea, then the river becomes inactive. The erosion work of the river will be totally stopped. Okay, that means the river will be dead. But when the sea level is lowered, see here in this case, okay, the level of the river bed is equal with the sea level, that means that the river becomes inactive. Here in this case, the river will be inactive. But when, if this lane is uplifted, okay, see, for example, is uplifted up to here, then in this case, here the river bed is higher than the sea level, and at this case, in this case, the river will start erosion. Okay, will start the work of erosion. Or when the level of the sea is lowered, if the level of the sea is falling down here in this case up to here, then we have got the slope. That means the level of the river bed is higher than the sea level, and that is why the river will start cutting downwards as well as sidewards, and this phenomenon is known as rejuvenation. Okay, see here in this case also, here base level here means the sea level. Okay, and in the first case here this level of the river is equal with the sea level, and here no work. But see, due to the upliftment of this portion of the lane, the river start cutting downwards. That means the river is resurrected. Okay, the river is revived, and this is known as rejuvenated river. Okay,
Yes, sir.
then these peninsular rivers form these trellis pattern, radial pattern, rectangular patterns. For this, let me show you this diagram. So here these peninsular rivers form this rectangular pattern. Okay, so in this case, these tributaries join the main stream at right angle here also right angle. In case of trellis, so this is also case of the trellis pattern. In this case also, the tributaries are joining the main stream at the right angle. But the difference is that in the case of rectangular pattern, the surface is covered with hard rocks only, and the rivers are flowing, the streams are flowing through the cracks and the joints. And for the trellis pattern, okay, the rivers are flowing through say following the soft rocks. So in this case, the surface is covered with alternate bands of the soft rock and the hard rock. Okay, so the rivers are following the these soft rocks, and these hard rocks will form the divides. Okay, and this is the case of this radial pattern. In this case, there will be a dome in the middle, and the streams are flowing in different directions. So this is the case of the radial pattern. And you must know that most of the peninsular rivers are forming trellis, radial, rectangular patterns, whereas the Himalayan rivers like the Ganga river Okay, then the Brahmaputra river, then other rivers are forming dendritic pattern. Next we have another basis, that is the nature of river. Okay, Himalayan rivers are long course. The rivers are very long, then following through the rugged mountains, experiencing headward erosion and river capturing. Okay, in the plains, meandering and the shifting of the course. So most of the Himalayan rivers are performing the work of headward erosion. Okay, headward erosion means the lengthening of a river's course by erosion backward from its source. Say for example, this is the slope of the lane, and let us say a river is flowing down the slope. Okay, and so in due course of time, this river will start cutting backward in this way. Okay, in this way the length of the river is increases. The river start the work of erosion backward, thus lengthening the river. So this process is known as headward erosion. Okay, so I will show you this photograph here. See here, this is due to headward erosion. Okay, see the river start cutting backward towards the slope, and so in this way the length of the river increases. Okay, then river capturing. So this is another phenomenon, and for the river capturing, see here. Okay, in this case, here a river is flowing here. Okay, so a river is flowing here. Here the level of the land may be higher than this river. Another river is cutting from this side, and let us assume that here this section of land is higher than this area. Okay, and because of that, because of this headward erosion, see here I have told you that this river is flowing, okay, in a lower altitude, and that is why due to headward erosion the length of the river will be increased, and in due course of time this river will cut this divide and will capture this river, as you see here. So the river starts cutting headwards and will capture this river flowing, okay, in the higher areas, as you will see here. Okay, as you are seeing here. So this river captures this area, this river, and so it becomes, this area becomes an abandoned river bed, and all the water of this stream, all the river water of this stream will be captured and will be pulled towards this river, and this phenomenon is known as river capture. Okay, and this point where this river captures, this river is known as elbow of capture. Okay, this is what I call the elbow. Okay, this is known as the elbow of capture, because from this, at this point, this river captures the waters of this river. Okay, and this is what we call river capture or river piracy. Okay, and in the plain areas the Himalayan rivers form meanders, and there will be frequent shifting. Okay, meandering, see here the river is flowing in this way in the winding course, that is known as meandering, and the river may shift frequently, sometime here, sometime it may be shifted here. This is known as shifting of the course, and meandering of the river. See here the river is winding. Okay, this is an example of river meander. Okay. And for the peninsular rivers, most of the peninsular rivers are these small, okay, are these smaller than have a fixed course and well adjusted valleys, means the streams are not shifting their beds, okay. And on the basis of catchment area, Himalayan rivers have a very large basins, and peninsular rivers have relatively smaller basins. On the basis of age of the river, okay, Himalayan rivers are young and youthful, active, and deepening in the valleys. Deepening in the valleys means downward cutting, okay. These are downward cutting. This is called valley deepening, okay. And for the peninsular rivers, most of the peninsular rivers are old rivers with graded profile and have almost reached their base level, okay. So graded profile, see here, actually in the this is an example of a graded profile, and here we have the sea, and this is the source region, maybe a mountain, and this is the base level, that is the sea level. And when we draw a cross profile of the river, okay, the profile is very smooth like this, no waterfall sometimes, okay, no rapids, and it is totally smooth, as you will see here, okay. So this is the first one, see the first one. So this is an example of this graded profile, okay. And most of the peninsular rivers have a graded profile like this, has a very smooth riverbed, okay, profile, thus reaching the sea, okay. And about the this base level, about the base level, and see here, okay, as I told you that the sea levels, okay, sea levels are the this is the sea level, and the sea level is the base level of erosion. This is the ultimate base level of erosion. And say if the river cuts up to here, then as I told you earlier, the river will become inactive. The river will not be able to erode the land when the level of the riverbed equals with the sea level. This is what we call base level erosion. And as mentioned in the book, most of the rivers in the peninsular India have reached the base level of erosion, okay. In addition to the ultimate base level of erosion, we have local base level of erosion. See here, if there is a lag, then the river will adjust, okay. So in this case, the river will adjust to the local base level, that is to the left. And here we have the sea. If there were no such lag, then this will be the profile, okay. This will be the profile of the river. But since we have this lag, the profile has been adjusted here, okay. Okay, are you clear? Any question from your side?
No, sir.
Okay, then let us continue, okay. Next we have these river regimes, okay. What do you mean by river regimes? Is given here. The pattern of flow of water in a river channel over a year is known as its regime, okay. The pattern of flow of water in a river channel over a year is known as its regime, okay. How much water is flowing in a river bed, okay, in a year is known as river regime. What is the total volume of water flowing in the month of in the summer season? What is the total volume of water flowing in the winter season? That is what we call river regime, okay. The North Indian rivers originating from the Himalayas are perennial, as they are fed by glacier through snow melt and also receive rainfall water during rainy season, that you have known. And the rivers of the South India do not originate from the glacier, and their flow pattern witness fluctuation. You will find variation in the flow pattern. The flow increases considerably during the monsoon rains. For the peninsular rivers, the flow of the river increases during the monsoon rains, and thus the regime of rivers of South India is controlled by rainfall, which also varies from one part to another part of the peninsular plateau. Okay, the discharge is the volume of water flowing in a river measured over time. So what do you mean by discharge? Discharge is the volume of water flowing in a river measured over time. So discharge is measured either in cusacks. Discharge of a river is measured either in cusacks. Cusacks means cubic feet per second, or cumax. Cumax stands for cubic meters per second. And about the river regimes of the two important rivers, okay, the Ganga has its maximum flow during January to June. The Ganga has its minimum flow, okay, minimum flow during January to June period, and the maximum flow is attained in August or in September. So after September, there is a steady fall in the flow, and the river thus has a monsoon regime during the rainy season. That means between June to January, Ganga river is mainly fed by this melting of the snow, and when August and September comes, then there will be monsoon rainfall, and there will be more water will be added to the Ganga river, and that is why there is maximum flow in the months of August or September. And there are striking difference in the river regimes in the eastern and the western part of the Ganga basin. Okay, the Ganga maintains a sizable flow in the early part of summer due to snow melt before the monsoon rains begin, as I told you. Okay, and the maximum discharge of Ganga at Farakka, that is in the western part of the Ganga plain, at Farakka is about 55,000 cusacks, while the minimum flow is only 1,300 cusacks. Okay, and the two peninsular rivers display interesting differences in their regimes compared to the Himalayan rivers. The Narmada has a very low volume of discharge from January to July, but suddenly it rises in August when the maximum flow is attained. That means at this time the monsoon rainfall arrives. Okay, in the month of August there is monsoonal rainfall, and that is why the maximum flow is attained. The fall in October is as spectacular as the rise in August. That means in October again the flow is again falling down. The flow of water in the Narmada is as recorded at the Garu Deshwar shows a maximum flow, okay, is of the order 2,300 cusacks, while the minimum flow is only 15 cusacks. This is for the Narmada river. The Godavari has the minimum discharge in May, and the maximum discharges in July and August. Okay, controlled by rainfall. After August, there is a sharp fall in water flow, although the volume of flow in October and November is higher than that in any of the months from January to May. The mean maximum discharge of Godavari at Polabharam is 3,200 cusacks, while the mean minimum flow is only 50 cusacks. Okay, so these are the regimes of important rivers like the Ganga, then the Narmada, and the Godavari. Okay, so in this way, depending on the amount of rainfall, depending on the melt of the snow or the glaciers, okay, the volume of river is different. And last, we have this extent of usability of river water. Okay, we know that the rivers in India carry huge volume of water per year, but it is unevenly distributed both in time and space. Okay, the distribution of this water is uneven both in time and space, and there are perennial rivers carrying water throughout the year, as we learned earlier, while non-perennial rivers have very little water during the dry season. Okay, and during the rainy season, much water is wasted in floods and flows down the sea. Similarly, when there is flood in one part of the country, the other areas suffer from drought. Okay, and can you suggest some of the measures to mitigate the problems of flood and drought simultaneously? Just we have learned that while we are facing flood in one part of the country, there is drought in other parts. So can you suggest some measures to mitigate the problems of floods and drought simultaneously? Here, for the local level, okay, here what we can do is that, say for example, this is a flooded area. Okay, so this is a flooded area, and this is a dry area. And if we dig a canal here, if we dig an inundation canal here, then the flood water of this area, okay, can be carried to the dry areas. Okay, this is one of the solutions. And another one is this inter-basin linkage. Say for example, this is a river flowing in these wet areas. This is a perennial river, let us say, and this is a seasonal river. Okay, and if we link these two rivers by a canal, okay, this is what we call this inter-basin linkage. So the water, okay, of this river may be diverted to this dry river. This also can be done. Okay, and see, here is the solution by transferring the surplus water from one basin to the water deficit basin, and this is what we call, okay, schemes of inter-basin linkage. Okay, and so this inter-basin linkage has many advantages and disadvantages. It also has environmental concerns also. Okay, and so we have to analyze whether it will be beneficial to us or may not be. Okay, we have to assess it properly, and we may face some problems also. See here, one side post question is here. Do you think that digging a canal is enough to transfer water from Ganga Basin to the Peninsular River? Transferring of water from Ganga to Peninsular River sometimes may not be possible, because here one is, okay, plain area, low-lying area, then Peninsular Plateau is a highland, and here the surface rock is very hard, and the digging of canals is maybe difficult. Okay, and that is why the transferring of water from the Ganga plain to the Peninsular may not be successful due to the unevenness of the terrain. Okay, and after this, here, how do you rank the following problems in using the river water? Okay, so we have to rank the most problematic one as the rank 1, and the least one should be at the bottom. So here, number 1, no availability of sufficient quantity. This is problem number 1. Then number 2, river water pollution. Then lot of silt in the river water, uneven seasonal flow of river, then river water disputes between the states, then shrinking of the channels due to the extension of settlements toward the tallweg. nowadays houses are constructed on the bed of the river also, and that is what we call shrinking of channels due to extension of settlements towards the talweg. Talweg refers to the bed of the river. Okay, so out of these 6 problems, I think the most serious one, okay, is the river water pollution. This should be the rank 1, okay, in terms of problem. So we are facing this problem, river water pollution. Okay, this is the most serious one, and if the water is polluted, then we cannot use it. Even for the industrial purposes also, we cannot use the river water. So this is the one, and others you may rank it. It is up to you. Okay, others maybe these river water disputes between the 2 states. Okay, then another problem maybe the third, maybe this one, shrinking of channels. Okay, and these others are natural. Actually, these lot of silt in the river water means deposition of the stones and the sands in the river. This is a natural process sometimes. Then uneven seasonal flow water, this is also a natural phenomenon due to the differences in the rainfall and so on. Okay, then the last part, why are rivers polluted? We know that see, when we release dirty waters of cities, okay, into the rivers, then river water is polluted. And when we discharge the industrial effluents and toxic waste material, okay, into the river, then the river water is polluted. Okay, and sometimes most of the cremation grounds are on the bank of river. Burning of dead bodies is done on the bank of the river, and the dead bodies are sometimes thrown into the river, and hence the river is polluted. In this way, the Ganga river is polluted. Okay, and on the occasion of some festivals, the flowers and the statues are immersed in the rivers. We are throwing down the flowers and the statues at the time of festivals, and thus polluting the river. Then large-scale bathing and the washing of clothes also pollute the river water. Large-scale bathing, we may give examples of Kumbh Mela. So on this festival, okay, millions of people are taking bath into the Ganga river, and hence the Ganga river is polluted. And to solve this problem, okay, to solve the problems of Ganga river pollution and Yamuna river pollution, we have Ganga Action Plan. Okay, and in the previous lessons also we have discussed about the Namami Gange program. Okay, so you should remember that one. And about the basin linkage, so we may examine this map. Okay, so here this map shows the proposed interbasin water transfer links, and here according to this index, this green color, okay, green set represents approved one. Say for example, number 24, Ken Betawa, this is approved one, and let us find out here. Transfer of water between Betawa and the Ken. So this is an example of interbasin linkage, and this is an improved one. And these are the other proposed one. Okay, here you may be seeing these lines. So all these lines shows the linkage of this Harda with this Sabarmati. In this way, linkage of this Gandhak with Ganga, like this. Okay, so you may examine this map. And here in the South India also, okay, we have the plan of linking Godavari with Krishna here. Okay, so these are the projects taken by the central government. The name of the project is National River Linking Project. Okay, so this project envisages the transfer water from surplus basins where there is flooding to water deficit basins where there is drought or scarcity. Okay, by network of reservoirs and canals, and this can be done. Okay, are you clear? Any question from your side?
No, sir.
Okay, then thank you very much for joining my class.